Okay, let's look at this question. So the question says if magnitude of 3a, a is a vector, right, is equal to 24 centimeters. Magnitude of 2b, b as another vector, is equal to 10 centimeters. And then the magnitude of 3 times a minus 2b is equal to 20 centimeters. We got to find the vector a plus b, right? So that's the question. So now, something to know about is that if you want to find a vector, there are two ways to represent a vector, which is you either represent it using the coordinates, right? So the horizontal and vertical sectors, or what you can do is that you can use the what is it? You can use the magnitude and direction method, right? So that's this. Okay, so let's do this, right? First of all, it will be good to start with setting A and B, right? Setting them up so that we got the horizontal and vertical components, right? And then we can go about it. Let's use the simple information first, okay? So the magnitude of 3a is equal to 24. This is a good piece of information because I can use the magnitude formula to write it out. But first of all, let's just write it in the form of A1 and A2, right? Okay. But then I can represent this guy as, yeah, 3A1, 3A2, right? This is just extending a vector by 3, right? So that's obviously is going to be like this. So then now we go for the magnitude calculation. That will be 3a1 all squared, right? Plus 3a2 all squared. Oh, and then now get rid of the magnitude line and draw the square root, right? If you don't know how the square root came from, this is a Pythagorean theorem, right? But yeah, like if you're not familiar with that, make sure you go back to review it a little bit, right? To make sure that this is all fine, right? And then this will make sense. Okay, so we have this, and then we continue, right? This is 9a1 squared plus 9a2 squared. You can factor out a 9, right? And then therefore take out the 9 from the square root, right? So we factor out a 9. That will make it look like this, right? 9a1 squared plus a2 squared, right? And then you take out the 9 from the square root. That's going to make it like this. But then now if you look at it, square root a1 squared plus a2 squared, that's just the magnitude of a alone, right? This part is just the magnitude of a, right? So then now, right, this just looks like 3 times magnitude of a, right? But then what's convenient is that we know that this is all equal to 24. So you got 3 times the magnitude of a is equal to 24. You can find out the magnitude of a alone, right? So then in this case, magnitude of a is equal to 24 divided by 3, which is 8 centimeters. There we go, right? Okay, and then let's look at the second piece of information, right? Which is 2b, the magnitude of 2b, right? So we'll do this similar thing, but then upon discovery, right, we found out that when you have something that's written like this, right, the conclusion is that you can actually just take out the value in front, right? So magnitude of 3a, that's just 3 times magnitude of a. So then similarly for magnitude of 2b, you can take out the 2, right? If you don't believe me, just try it out on your own, right? So do it the long way, and then you'll figure out that eventually it turns out to be 2 times the magnitude of b. But to save some time, right? I'm not going to do it the long way because it's going to take a lot of time and make this video unnecessarily long. So I'm just going to go for B right away, okay? So then the next thing, right? We got these two pieces of information. The last piece that's good to use would be I need to do something about this guy, right? The 3a minus 2b, right? That one. This is probably the hardest one. So when you do it, make sure that you're careful, right? So I'll scroll down, okay, to here, and we'll play with it, right? So 3a minus 2b. I'm just going to write it again, right here to remind myself that, oh, this is equal to 20. Okay, and then after that, we just do the whole spill, right? Which is, write it as the, in the horizontal and vertical components, right? In that form, okay? So that's going to look like this. That's equal to 20. Okay, all right. So then combine them together into one thing, which is 3a1 minus 2b1, comma, right? So that's the horizontal component. And then the vertical one, do the same thing. There, right? Okay, that's equal to 20 centimeters. And then now you want to figure out the magnitude of this vector is very easy, right? Again, Pythagorean theorem, which is, you do the first guy squared, and then plus the second guy squared, and all of it inside the square root is equal to 20, right? So let's do that. All of it inside the square root, the horizontal component, right? All squared, plus the vertical component, all squared, right? And then that's equal to 20. So now there's some algebra that we need to do, right? Expand the brackets to see how it looks like. So let's do that, right? Square root again, okay? Now, this is, if you do it fast, right? This is 9a1 squared minus, I think it's 12, right? a1, b1, plus 4b1 squared, right? If you cannot do it that fast, just do it slowly, right? Make sure to have an intermediate step in the middle, right? But yeah, eventually it's going to be like this, okay? And then you continue, right? So plus, right? Remember, this is the first part. You still got to expand the second part, right? So the second part is 9a2 squared minus 12 a2b2 plus 4b2 squared, right? And that's equal to 20 centimeters, okay? If you don't want to write the 20, yeah, you can forget about it for now, but make sure to include it at the end because we're going to use it eventually, right? Okay, so now, right, if you look at this, there's some things that look very similar, right? You see that a lot of terms have like similar coefficients. So it'll be good to kind of reorganize the things inside and group them, right? So we'll group them. We'll put the terms with the coefficient 9 together. And then there are also terms with coefficient 12. Well, negative 12. So we'll put them together. And then the last guy is the coefficients with the terms with a coefficient 4. We'll group them together. And of course, all of this is equal to 20. But if you're feeling annoyed, yeah, you don't have to write that for now. But yeah, let's keep going, right? So now I'm kind of starting to see a little pattern here, which is, yeah, you can factor out the 9 from everything, right? Of the first two. You can factor out a negative 12 of the second part. That's a plus, don't forget, right? And then plus that. By the way, right, if at any point of this you're feeling a little confused, just pause the video and take some time to think about it, right? Okay, and now if we keep going, this is, well, if you look at a1 squared plus a2 squared, that looks very familiar, right? And if you scroll up, that looks like what's inside the square root when you calculate for magnitude, right? So then magnitude is square root a1 squared plus a2 squared. This guy right here does not have the square root, which means is the magnitude squared, right? So if you look at it, this is 9 magnitude of a squared, right? Because the square root is gone, right? But the magnitude itself has the square root, so you got to square, right? Okay, and then now if you look at let's skip the middle, right? So you look at this part, right? That looks also very familiar, right? Four times the magnitude of b squared, right? It looks like that, right? Okay, and then we'll deal with the middle because the middle is like the weird one, right? So then now, if you look at the middle, this is something that you have to know, which is if, like if you don't remember, what's in the middle calculates the dot product, right? So for example, right, if you have a dot b, a and b being two vectors, you will have two ways to go about it, which is one of the ways is you do a1 b1 plus a2 b2, right? That's one of the ways to go about it. So then if you look at it, right, this is minus 12, technically a dot b, right? And we know that a dot b is a scalar, so it gives you a quantity, right? So that's something that's good to know, okay? But then also, don't forget that another way to calculate the dot product is that you use the magnitude of both of the vectors, and then you multiply it by the cosine, okay, of the angle in between them. Of course, theta being the angle between A and B when they're arranged from tail to tail, okay? So that's the idea here. So then we're going to do that here because rewriting this as a dot b doesn't help us to do anything. But then rewriting it in another way gives us some clue, right, about some things down the line, right? So don't know what that is, right? But we're gonna discover it to see, right? So, oops, gotta change it to blue. So now this is 9a squared plus 4 magnitude of b squared minus 12. And then now you're going to write it as magnitude of a, magnitude of b, and then cosine theta, right? Okay. And now a lot of these are quantities that we already know, right? Magnitude of a and magnitude of b, we already calculated. So we'll plug it in, right? And then let's just scroll up, right? Just to remind ourselves that magnitude of a is 8. Magnitude of b is 5. So we're going to plug that in, okay? So we'll plug that in here. That will be, okay, 9 times, well, that's 8 squared, so 64, plus 4, well, that's 5 squared, so 25. And then minus 12, keep going, right? 8 times 5, right? Magnitude of 8 is 8. Magnitude of b is 5. Don't know what cosine theta is, but it's okay. Yeah, leave it there. Okay, and then we just calculate, right? So if you have a calculator at hand, that'll be very convenient, right? So if you do it very quickly, right, 9 times 64 is 576. This is 100. And then minus now, this is just multiplication, right? Everything is multiplying each other. So you can just multiply the numbers first, right? So 12 times 8 times 5, that's, again, if you do it quickly, that's 480. So you have this. But then now, don't forget that all of these is equal to 20 on the other side. So you can square both sides now, right? Or if you don't want to, right, then actually you kind of have to now. So yeah, let's combine the things in the bracket first, but also square both sides. So now it's going to be 400 on the other side, right? Okay, and then the rest is pretty easy. So I'm just going to work through it very quickly, okay? So this is equal to this. So cosine theta is equal to, if you use a calculator to calculate, right? Let's punch it in. That's, hold on. Yeah. Okay. That's 0.575. So therefore, theta is equal to, let's just use our calculator again. That's about 55 degrees. Yeah. Okay. All right. So we figured out the angle. And then now, right, the last thing would be we need to figure out the magnitude of a plus b, right? But then all of that is pretty simple, right? Because to figure out the magnitude of a plus b, you simply do the magnitude formula, right? Okay, I'm running out of room here, so I'll just put another page below. Okay, all right, let's do that. So magnitude of a plus b, right? It seems like, because we already got the angle, so the direction of the thing is already figured out, then it would be good if I can just figure out the magnitude and then call it a day, right? So which means that the approach towards solving this question is that, yeah, we go for magnitude and direction, not the horizontal and vertical components of this guy, right? So let's go for the magnitude very quickly. So for this part, if you're really bored, you don't have to worry about it, but I'm just gonna do it quick, right? Which is, this is gonna look like this, right? Because when you do a plus b, the horizontal and vertical components, they will combine, right? And then you would do the horizontal component squared and the vertical component squared, right? So that would be b2 plus, a2 plus b2, yeah, all squared, yeah, like that, right? Okay, and then just expand some stuff, right? By the way, right, if you don't know how I got this, right, you should take it slow and figure out what magnitude of a plus b is, like write it using horizontal and vertical components form, and then you will know how it looks like this square root here, okay? But to save some time, I'm gonna skip that part. So this is this, right? If you expand the brackets, that's this. Yeah, by the way, right, if any of these feels a little fast, feel free to pause the video, right? And then the second part is this. Okay, and then reorganize, right? We organize, and then that will be this, okay, plus this, plus this, right? Put the terms that look similar to each other together. Okay, and then now this looks like, well, I know that, again, right, a1 squared plus a2 squared, that's just magnitude of a all squared, right? Second part also, magnitude of b all squared. And then the last guy is, well, if you factor out the 2, that's just 2 times the dot product, right? But we already have the angle, right? So it would be good to now rewrite it as this. Yeah, I know this is a long question, but yeah, just bear with me. So that's gonna look like this, right? And then cosine theta, which we already know, right? What cosine theta is. So now the last thing would be plug in all the numbers, and then you will be able to figure out the answer. So this is 64 plus 25 plus, now the last thing is 2 times 8 times 5, right? Times cosine theta, right? Well, cosine theta, we also just calculated from the last part. Cosine theta is 0.575, right? So 0. So we'll write it here, 0.575. Yeah. Okay. All right. And now the last thing would be plug everything into the calculator. So I'll do that very quickly. Okay. Okay. 2 times that times that. Okay. And then after plugging in everything, don't forget to square root. Yep. So the answer turns out to be about 11.62 centimeters. Okay, so then to conclude the question, right? A plus B is 11.62 centimeters at the angle, so make sure to mention the angle, right? At 55 degrees. And that's it. Yeah, that's pretty much everything. If you got any other questions, feel free to let me know. Or if you realize that I could do the question better, feel free to let me know as well. But yeah, other than that, I hope this helps. This is Walter, Alight Education. I'll see you next time.